Welcome back for the third and final installment of the AP ECE Chemistry Chapter 9 Liquids and Solid Problem Set. I'm Mr. Wilkosz. Let's take a look at problem number 39. In problem 39, you're asked to classify solids with given properties as either metallic, network covalent, ionic, or molecular. So you're told in part A that the substance is insoluble in water, melts above 500 degrees Celsius, does not conduct electricity in any state whatsoever. Those three things should lead you to the conclusion that it is a network covalent solid. For part B, you're told that the substance dissolved in water, does not conduct electricity in any state, and that makes it most likely to be a molecular substance. If it were an ionic substance, it could dissolve in water, but then it would conduct electricity in the molten state, the liquid state. For part C, it dissolves in water, melts above 100, conducts electricity in the aqueous state. That's an ionic substance. And so the one that you're not working with here is a metallic thing that would probably not dissolve in water. It could have a variable melting point, and it would conduct electricity in all states. Let's take a look at 43. For problem 43, again, you're classifying something as molecular, network covalent, ionic, or metallic. And this is based now simply just upon what element or compound it is. So you have to recognize that sodium, being on the left side of the periodic table, would tend to give away its electrons, and that makes it a metallic thing. It would be bonded by a sea of electrons. For part B, you have to recognize that a metal, sodium put together with a polyatomic ion, sulfate, would make an ionic compound. When in part C you have two nonmetals, carbon and hydrogen, you have to recognize that that will be a molecular substance. C60 just has a huge amount of carbons, and that would give you like a network covalent thing, but I guess if you don't consider that to be huge, you could classify it as a molecular substance. And HCl, in its aqueous form, hydrochloric acid, has an ionic nature to it. For the last problem, number 69. You're asked to classify something, some statement with a blank as either less than, greater than, equal to, or MI for more information needed. In part A, you're told that at 50 degrees, benzene has a vapor pressure of 269 millimeters of mercury. A flask is described to you as having both a liquid and a vapor present, and they want to know what the vapor pressure would be. Would it be equal to, more than, less than, or you need more information than 269 millimeters of mercury? If there's both liquid and vapor, you have reached the maximum capacity for the vapor in that flask, and then the remaining stuff stays as a liquid, and then you're just equal to vapor pressure at 269. You kind of have to assume that it's at 50 degrees still. For part B, you're told that ether has a vapor pressure of 537 millimeters of mercury at 25 degrees Celsius, and a flask contains only ether vapor at 37 degrees Celsius, and you want to know if the pressure is greater than, less than, equal to, or more information is needed than 537. If the flask contains only ether vapor, you could be exactly right at the capacity of the flask, and it would be like exactly equal to 537 millimeters of mercury for vapor pressure. But if you had some smaller mass of ether, it's possible that it could be sorry about that. It's possible that it could be less than 537 if it was well below the mass that would be to fill the capacity of the container. Alright, for 69 part C, the boiling point of water, it should be greater than the boiling point of propane because water has the capacity to hydrogen bond, whereas propane does not. The energy needed in part D to vaporize liquid bromine should be less than the energy needed to decompose Br2 atoms in Br2 molecules into plain Br atoms. Vaporize is going to be a change of state, so you kind of have to imagine me moving my fingers around as a liquid and then flying them up as a gas, but it's still bromine. Now, to get from Br2 to Br, you really have to snap bonds, and that's a lot more energy required. And then for part E, the dispersion forces for a larger molecule, C10H8, should be greater than the dispersion forces for a smaller molecule, C4H10.